Yeah, good morning all. So today in this class, let us discuss about waves, types of waves, right? Their characteristics. So, when you go for a picnic, if any lake is present nearby your picnic spot, what you will do? You will just pick a stone, throw it into that water. Did you observe what happens when you throw the stone in the water? Yes, disturbance is created in the water. In that still water, when you throw the stone, a disturbance is created. Will the disturbance remains there only? Did you observe that? Will the disturbance remains at that place only? Stops there? No. This disturbance moves in forward direction. So that disturbance, how it is moving in forward direction. And what is that disturbance we call? Here, the disturbance created at that particular position, we call it as wave. Then what is it? That particular thing which is carrying this disturbance in forward direction, that we call it as medium. So medium means nothing but that particular thing which makes these waves to travel in forward direction or carries the waves in forward direction. So such mediums may be gas, solid and liquid. Alright? Now when you throw a stone here, you will find some circular disturbance created at that particular point. And that disturbance travels in a forward direction. And this medium will carry this wave in a forward direction. That medium will carry the wave in a forward direction. So actually what happens here means, when you throw the stone in the water, then the particles of water starts vibrating. And this vibration passes from one particle to other to other in such a way. Vibrations transfer from one particle to other particle. And these only comes out as waves. Right? Now, totally wave means nothing but a disturbance created in the medium. And medium means that particular thing which is forwarding the or carrying the wave in forward direction. This medium will be solid, gas or liquid. Alright? Now these waves are classified into three types. One we call it as mechanical waves. Second we call it as electromagnetic waves. Third one, matter waves. Okay. So mechanical waves, electromagnetic waves and matter waves. First, let us discuss about mechanical wave. These mechanical waves require medium. They require medium. And these mechanical waves are governed by Newton's law. Newton's laws. Right? Here I am saying it required the medium. The medium is gas, liquid, solid. Right? And The example for these mechanical waves: sound waves, light waves, etc. Right? Next, electromagnetic waves. Electromagnetic waves, they require medium, as well as if medium is not present, they will travel through vacuum also. What is vacuum? Vacuum means an empty space where there will be no dust particles, air particles, anything. So, electromagnetic waves, not only they travel through the medium, but also they travel through vacuum also. Then how these electromagnetic waves are formed? How means? Now the changes in electric field give rise to the magnetic field. Right? We call it as electromagnetic theory. What electromagnetic theory is saying? Electromagnetic theory says that when electric field changes, it converts into magnetic field. When there are changes in magnetic field, an induced EMF is generated. So this continuous changes in electric vectors and magnetic vector components give rise to the electromagnetic waves in such a way. Okay, give rise to the magnetic waves, and the speed of these electromagnetic waves will be equal to the speed of light. The speed of electromagnetic waves will be equal to the speed of light in vacuum, that is 3 into 10 to the power of 8 meters per second. Right? Now the third one is matter waves. Matter waves means if any particle moves, then a wave is associated with that particle. The wave is associated with that particle. So that waves, we call it as matter waves. Proton, electron, when they move, a wave is associated with an electron. So such waves also move along that particular particles. That we call it as matter waves. So in such a way, waves are classified into 3 types: mechanical waves, electromagnetic waves and matter waves. Right? Now let us go for the discussion of mechanical waves. Alright? So before going for that, do you know about progressive waves? The word itself is saying these waves progress in forward direction and never return back to the original position. That we call it as progressive waves, comes under the mechanical waves itself only. So progressive waves, So progressive waves means that particular waves which move forward in a forward direction and never returns back. To its original position from where it has started. That we call it as progressive waves. Such progressive waves are classified into 2 types. One is transverse waves, other is longitudinal waves. Alright? First let us discuss about transverse waves. So transverse waves means if this is the direction of propagation of wave, okay, the direction of propagation of wave, then how the particles will vibrate? Here the particles will vibrate in such a way. In such a way means the particle is vibrating in a direction perpendicular to the direction of propagation of wave. Here the particles are vibrating in a direction perpendicular to the direction of propagation of wave. So such waves we call it as transverse waves. Then how can you produce transverse waves? Take a rope, tie it at one end, and with your hand just make the rope to move in such a way. Okay, then in such a way waves are created and their vibration is perpendicular to the direction of propagation of wave. So what are transverse waves? If the direction of vibration of particles are perpendicular to the direction of propagation of waves, we call it as transverse waves. Right? And now the examples for these transverse waves are light waves, rope waves, okay, electromagnetic waves, etc. Now here let us see this waveform in such a way. Right? Here you see these we call it as crest. These we call it as trough. So transverse waves travels in form of crest and trough. Alternately we will get crest, trough in such a way. So transverse wave moves in form of crest and trough. Now crest means highest parts of the wave. Crest means highest parts. And this is the lowest parts of the wave. The lowest parts of the wave. Right? Now let us move for longitudinal waves. Now this is direction of propagation of wave. Right? The direction of propagation of wave. Now here the vibration of particles will be in such a way. So this is the vibration of particles. The vibration of particles are parallel to the direction of propagation of wave. The vibration of particles are parallel to the direction of propagation of wave. Right? So now here the examples of such waves are sound waves, seismic waves, etc. Do you know what are seismic waves? So these waves produce before the earthquake comes. So wherever the earthquakes are occurring, before the earthquake occurs, these waves will be produced in the crust of the earth. And through these seismic waves only we can find the intensity of earthquake. Right? So seismic waves, sound waves are some of the examples for longitudinal waves. Now here, as transverse waves are travelling in form of crust and trough, even longitudinal waves also travel in form of compression and refraction. Here how the transverse waves is moving in form of crust and trough. Here these move in form of compressions and rarefactions. So in such a way, I am drawing the compression. See how I am drawing? I am drawing all the particles very closer to each other. Now these are rarefactions. Alternate compression and rarefaction will be there. Compression, rarefaction, compression, rarefaction. Now see. So these are the compressions. How the compressions are there? All particles are very closer to each other. All particles are very closer to each other means the density there will be very high. The density of particles will be very high. And you see the rarefactions. These are rarefactions. Particles are very distant from each other. Here particles are very closer to each other. So density will be more. Such parts of the wave we call it as compression. Now in rarefaction, particles are at a distance from each other. The density of particles will be less. So this we call it as rarefraction. Right? So this is about the transverse waves as well as longitudinal waves. Right? Now let us go for the basic characteristics of waves. Let us go for the basic characteristics of waves. Four characteristics are there. Amplitude, wavelength, frequency and speed. Alright? Now one after another let us see. First, amplitude. Now this is the wave. Right? Now this points we call it as maximum displacement points. Maximum displacement points. Right? Now this maximum displacement points we call it as amplitude. So what is amplitude? Maximum displacement points. That we call it as amplitude. Now next, wavelength. Next, wavelength. So now here I am drawing a wave. Either you can take compression and rarefactions also, longitudinal waves, crust, trough. The distance between any two crusts or the distance between any two troughs, we call it as wavelength. The distance between any two crusts or the distance between any two troughs, we call it as wavelength and denoted with letter lambda. Alright? Even in case of longitudinal waves also you can define as the distance between any two compressions or the distance between any two rarefactions. That we call it as wavelength and denoted with the Greek symbol lambda. Next, frequency. It is denoted with a Greek letter nu. Okay. So now frequency. In particular time, how many oscillations are taking place? So oscillation means what? The to and fro motion. Here the to and fro motion. This we call it as one complete time period. Okay. So one crust, one trough will come. One complete time period we will call time. taken for the wave to travel. In such a way, the number of oscillations per second, we call it as frequency and denoted by letter nu, and units are hertz. Right? Now next is speed. Now speed means frequency into wavelength. Okay? It depends upon frequency as well as wavelength. In such a way we can also write, this is written as, if V is the speed, nu lambda. Or we can also write frequency is equal to V by lambda. We can write wavelength in terms of wavelength as lambda equal to V by nu, in such a way. So this is about the speed. The speed of wave, it is written in terms of frequency and wavelength as V equal to nu lambda. Now next, let us go for some small equations related to these sound waves, which will be helpful for you in your entrance exams. So first, the equations related to sound. V equal to velocity of sound under root E by rho, where E we call it as bulk modulus, rho density. In adiabatic process, we can write E as, if P is the pressure, E is written as gamma P by rho. Do you know what is gamma? Gamma is nothing but Cp by Cv, the ratio of specific heat, molar specific heats. We call it as gamma. So in adiabatic process, if we consider the ratio of molar specific heats gamma, and if P is the pressure, then it is written as gamma P by rho under root. Right? Now even we can write in terms of Young's modulus, Y by rho. Y is the Young's modulus. Do you know what is Young's modulus? Nothing but stress by strain. Then what is stress? Force acting on unit area, we call it as stress. What is strain? The deformation created in the body when we apply the force. Means if we take any rod, any wire or a string and hang the weights to it, what happens? String elongates. Means its length is increasing. Length is increasing means a deformation has created in that body. Right? So that change in length to original length, we call it as strain. Nothing but deformation created in the body by application of external force. Right? So Young's modulus is nothing but stress by strain. Now what is the relation between velocity of sound and temperature? Velocity of sound is directly proportional to the absolute square root of absolute temperature. The velocity of sound is directly proportional to the square root of absolute temperature. So this is about the waves and also the types of waves, their examples. It will be very useful for preparing for competitive exam, and on this particular maths part he may ask some problems. Read the question well, understand the question, write down what parameters he have given in the problem, and just if you are perfect with the formulas, easily you can attend any problem which given in your competitive exams. So stay with my channel Reshma Physics. In my next video, I am going to say more about the sound. Thank you.